All right, we have an excellent, we still have some people here. Jadine's still here, excellent. They called her simply physics, excellent. Lana's joined us, Lana's excellent. Jackie's leaving soon. Carly's gonna be here very late, I think, but that's okay. All right, we're gonna do A as in Alfred, 8 as in ate the soup. Okay. Sydney is home from school with a cold. So Mom made him a bowl of chicken soup, which is mostly water. I guess it was chicken broth. I know, not much stock, huh? All right. And she ladles it from a pot into a glass bowl. If 0.6 kilograms, so this is, remember, this is 0.5 kilograms, so it's a pretty big bowl of soup, don't you think? It's pretty big. A 0.6 kilogram bowl of soup, 90 degrees Celsius, that's pretty hot, is placed in a 2.2 kilogram bowl that is initially at 20 degrees Celsius. We're assuming 20 degrees Celsius is room temperature. Let's do a 20 degrees Celsius check. Let's multiply 20 times 1.8 plus 32. 68. Okay, going back to the Nixon years, which you're too young to remember. Nixon wanted all the households to be put down to 68 degrees. Personally, I find that chilly for some people, 68 degrees. Okay. So we want to know when all right, think about what's happening. This hot soup is being put into this cooler.
All students taking the 315 late bus, please report to the bus board and cafeteria area at this time. All students taking the 315 late bus, please report to the cafeteria area at this time. Bye.
Bye, Judy. You picture what's going on? You're putting this hot soup into a cold bowl, right? And some of the energy is being lost from the soup, and it's going into warming the bowl. You get it? So we know that the heat gained by the bowl is going to be the heat lost by the soup. Yes, I know there are a lot of variables in here, but we're going to assume all energy was adiabatic. Heat went to the bowl. Now, how do you know that it's not all going to the bowl? You pick that bowl up and it's hot. So energy is coming out of that bowl, right? But we're assuming that it all goes into the bowl, nothing goes into the atmosphere, nothing goes into the table. All right? So we know that the heat lost by the soup equals the heat gained by the bowl, correct? All right? So this is the soup side, right? Right?
Yes. We need to draw a picture of a soup bowl because.
Sure, you should draw a picture wherever you can.
Well,
draw
you
a
said
picture.
for your specifications.
Correct. Draw a picture. Draw a nice little bowl.
I did.
Okay, excellent. Okay.
I was just double checking.
Now. So this is the bowl, this is the soup side, and this is the bowl side, right? What was the mass of the soup? Do you remember?
0.6 kilograms.
0.6. So 0.6 kilograms, and then TF minus, was it 90 degrees? It was hot soup,
Yeah.
wasn't it?
Yeah.
Is that right?
Yeah.
And then 4187 joules per kilogram degree Celsius is the specific heat capacity of water.
Water.
Remember we said the soup is mostly water.
Okay.
Okay, so then this is going to be negative. Do you remember the mass of the bowl? Wasn't it
2.2.
0.2? So 0.2 kilograms TF minus the temperature of the bowl was room temperature, 68 degrees Fahrenheit or
20 degrees.
20 degrees Celsius. And the specific heat capacity of glass,
840.
840, which is sand, which that's pretty close. 840 it says?
Yes.
Okay. Yeah, sand is about 800-ish, between 8 and 900. Sand, quartz. Okay. And glass, as you know, is mostly sand, with a few other odds and ends thrown in. All right, good. So let's simplify both sides. 0.6 times 4187. 0.6 times 4187.
2,512.
What is it?
2,512.2.
All right, 2,512.2. We'll leave off the 0.2. Just makes things a little bit look a little nicer.
TF minus 90.
What is 0.2 times 840?
168.
168. Okay, looking good?
Yes.
All right. Distribute this now. 2512 times TF is going to be 2512 TF minus what?
226080.
226
Zero.
00.
No, 080. 226080. There you go.
Yeah. I agree.
Is that right?
Yes, it is right.
Okay. Equals
Negative 168 TF minus 3,360.
what is it?
Is that what you got?
Yeah.
3,360.
3,360. What I'm going to do is I'm going to distribute that plus that minus sign in there at the same time. See that?
Yeah.
So I'm going to say negative that and then plus that, right? Is that right? Does that look good?
Yeah.
Are we here? Are we there? Yes?
Where did that negative sign come from?
That was from the original equation.
Okay.
Subtract.
Okay. Get it? Okay. Now, add 168 TF to both sides. Okay. So 2512 plus 168 is what?
2,680.
Is that correct?
Yeah.
Are we comfortable with that? All right, now add 226,080 to both sides. So you're in actuality going to be subtracting that from that, adding it, whatever. So what is 226080 minus 168?
What?
I'm adding it to both sides, right?
Wouldn't it be
Yeah, but-
3,360 instead? You
Yeah.
subtract it?
Because you canceled out the 168.
Yeah, that's canceled. You subtract negative 3,360 from 2,200.
Yeah.
Oh, I'm sorry, correct. I'm like looking at this.
Yeah.
Right, understood. It's this, and that to both sides, so it'll be 3,360 plus 226,080.
And you get a 229,440.
440.
40.
Isn't that nice when you can get rid of that decimal and you don't have to worry about that?
Yeah.
Yeah. All right, I'm going to erase this up top here. I don't have enough room down here, I don't think.
You have like a little bit of room.
Yeah,
Is that right?
you have enough room.
I have enough room?
Yeah.
Okay, so TF,
Equals.
so 229,440 divided by 2,680 equals
85.6.
85.6. Now, so first of all, the answer has to make sense to you. Does it make sense?
Yes.
Yeah.
So,
You're putting it in a cold bowl, so it's obviously going to not, you know, if the answer were greater than 90 degrees or less than 0 degrees, you know you did something. If you didn't put this minus sign in, you'd probably wind up with an answer less than 0 degrees. So it's got to make sense. So the answer has to be between 0 and 90, right? Between 20 and 90. Yes? It has to be greater than 20 degrees, less than 90. And it's probably going to be closer to 90 because water can hold 5 times more heat than glass. Ish. Okay? Ish. Yes? Excellent. Are we there? Any questions?
Nope.
So,
Easy peasy. Yeah. Keep going. This is our CPU sign.